Okay, the plan for this recording is to go through the graphing worksheet, talk through how I came up with the graphs. I'm going to use the enter key to help talk through these. I assume we're not having a problem. It might be a bad assumption, but I assume we're not having a problem coming up with the x-intercepts, y-intercepts, and so on. My assumption is going to be that most of the difficulties is coming in the graphing part. I'll still talk through some of the other things, but I'm assuming that the main difficulty is the graphing. So that is where I'll spend most of my time in my explanations. So first thing, if you don't have notes that tell you how to find these, as I describe them in words, you may want to write them down, pause so that you can write it down. First thing, x-intercepts. You find x-intercepts by finding values for x to make the top of the fraction 0. Values for x that make the top 0. So your first step would be to factor the top and figure out what values for x make the top 0. In question 1, it doesn't factor. It's already simplified. So what makes x minus 2 0 when x equals 2? And so my x-intercept is 2, 0. Next step, y-intercept. To find the y-intercept, it's the value of y when x is 0. So I plug in 0 for x. It is the easiest to plug in 0 into the original equation. So plugging 0 in for x causes all the x's to become 0, and you end up with just the constants. So I end up with a -2 over -5, which is really a +2 over +5. So my y-intercept is always going to be 0 something, and my x-intercepts are always going to be something 0. Vertical asymptotes. Vertical asymptotes are values for x that make the denominator, the bottom part, 0. So I factor the bottom, and I figure out what makes the bottom 0. The bottom in this problem factors into 2x minus 5 and x plus 1. And I solve those. X plus 1 is easy, but 2x minus 5 in class the other day, some of us are having a hard time figuring out when will 2x minus 5 equal 0. Just write out the factor, set it equal to 0, and solve. Add 5 to both sides, divide by 2, and x is 5 divided by 2, which is 2.5. Remember the shortcut. It's always the second number divided by the first number, but opposite sign. All right, so there's the x, or the vertical asymptotes. Horizontal asymptote. We are comparing the degree of the top to the degree of the bottom. Question 1, the degree of the top is less than the degree of the bottom. So my horizontal asymptote is 0. Okay, degree of top is less than the bottom. It will always be 0. The degree of the top is a 1. The degree of the bottom is a 2. The horizontal asymptote is 0. All right, what is the horizontal asymptote? That is where I start on my graph. My horizontal asymptote is y equals 0. What that tells me is as x gets really big, as x goes to infinity, what happens to y? It approaches the horizontal asymptote. The question I have to figure out is, does it approach it from the bottom or from the top? If it approaches it from the bottom, the y values will be negative. If it approaches it from the top, the y values will be positive. So one way of checking is just to plug in a fairly large positive y value. So I'm picking like 10. That's fairly large. It's something bigger than my x-intercepts and my vertical asymptotes. So plug in 10. 10 minus 2 on top, 2 times 10 minus 5, and x, which is 10, plus 1 on the bottom. Notice everything is positive. 10 minus 2 is positive. 10 minus 5 is positive. 10 plus 1 is positive. That parentheses in the wrong spot. Everything is positive. So my y value will be positive when x is going to infinity. And so it approaches it from the top. So my graph is going to come and approach infinity from the top. As my graph gets close to the vertical asymptote, it will either go to positive infinity, it'll go straight up, or it'll go to negative infinity. In this case, it can't pass through the x-axis over here, so it has to go up. When I switch, so what I do is I start on the right-hand side, and I figure out what does my graph look like on the right-hand side. Right-hand side of what? Right-hand side of my furthest asymptote to the right. My most right-hand asymptote, I start to the right of that, and I figure out where is my graph at. Once I know that, that tells me a lot. When I move from the right-hand side of that vertical asymptote to the left-hand side of that vertical asymptote, my y values will switch direction. If it went to positive infinity on the left, it will go to negative infinity on the right, and vice versa. It went to positive infinity on the right, so it will go to negative infinity on the left. So I know it comes from negative infinity, and it follows along that asymptote. It must pass through my x-intercept of 2 and my y-intercept of 2 over 5. It then must approach the asymptote at x equals negative 1. So either, like I said, every time you approach a vertical asymptote, it will go to positive infinity or it will go to negative infinity. I have to decide, does my graph go up or does my graph turn and go down? In order for my graph to turn and go down, it would have had to pass through the x-axis. It doesn't. The only place it passes through the x-axis, according to my information, the only x-intercept is at 2. It can't turn after it passes through the y-axis and go down, because that means it passes through the x-axis at like negative 1/2, and it doesn't. The only place it passes through is at 2. So no, it has to turn and go up. Same logic. Once I go from the right-hand side of this asymptote to the left-hand side of the asymptote, my y values switch directions. So it goes to negative infinity. It does not pass through the x-axis over here, but it does approach x equals y equals 0 as x goes to negative infinity because it's a horizontal asymptote. And there's my graph. Okay, question 2. Find x-intercepts, value of y that make the top 0. I have to factor the top. Factors into x minus 5, x plus 3. The bottom, x cubed minus 16x, factors a common term out first. So there's an x common in both of those terms, and that factors into x times x minus 4 times x plus 4. Okay? Now, x-intercepts occur when the top is 0. X minus 5 is 0 at x equals 5. X plus 3 is 0 at x equals a negative 3. Next, y-intercepts. Value of y when x is 0. Plug in 0 for x. That goes away, and that goes away. I end up with a negative 15 over 0. Not possible. You cannot divide by 0, which means there's no y-intercept. This graph will not pass through the y-axis. Vertical asymptotes. Values for x that make the denominator 0. That factor is 0 when x is 0. There's my first one. That should make sense. I have a vertical asymptote at the y-axis, which means I have no y-intercept, like we just said above. X equals 4 makes that 0. X equals a negative 4 makes that 0. So I have vertical asymptotes at negative 4. I have vertical asymptotes at a positive 4. And I have vertical asymptote at x equals 0. I will have 4 pieces to this graph. One piece over here, one piece in here, one piece here, and one piece over there. Okay, I have 4 pieces to my graph. All right, next step, plotting my x-intercepts. I have an x-intercept at 5, and I have an x-intercept at negative 3. Next step, I graph my part of the graph that is furthest to the right. As x goes to infinity, y approaches my horizontal asymptote of y equals 0. The horizontal asymptote's at y equals 0 because the degree of the top is less than the degree of the bottom. As x goes to infinity, does it go to infinity on the positive side? Sorry, does y go to 0 on the positive side or on the negative side? Will it be above or will it be below the x-axis? Plug in values for x. When x is positive, large values, both of these are positive, and so y will be positive. Or when I plug in large values like 5 or like, not like 5, but like 10 or 15, that's positive, and so on. They're all positive. It'll be on the top. It'll come down from the top and approach the horizontal asymptote. Here's the problem, or a weird situation. It approaches from the top, but it has to pass through this x-axis at 5. Well, if it's coming along the y equals 0 line, as x gets smaller, y is going to actually get bigger to a point until I get right next to 5, and then it'll go to 0. And then it'll keep going down and approach my vertical asymptote. How do I know it keeps going down and doesn't go back up? Because it does not cross through the x-axis again. Has to look something like that. In between, like we said on question 1, if it's going to negative infinity on the right, it'll go to positive infinity on the left. It does not pass through the x-axis in between those two asymptotes. So it must come towards the asymptote, or the x-axis, turn, and go towards the other asymptote, and go to infinity. As it goes on the right-hand side, it goes to the infinity. So on the left-hand side, it'll go to negative infinity. It must pass through the x-axis over here at negative 3. It must approach the vertical asymptote of a negative 4. The only way that happens is if it comes up, turns, and goes towards the asymptote. It does not come from the top because as I go from the right-hand side to the left-hand side, it switches from the top to the bottom. So it doesn't do this right here. Same logic on the right-hand side. When I switch to the left-hand side, it's on the bottom. It does not pass through the x-axis, but it does approach the x-axis as I go to negative infinity, and I get that graph. If you struggled on 1 and 2, and you've watched the video on 1 and 2, try to do question 3 on your own. Talk yourself through the different techniques that I've used. You start on the far right-hand side, use your horizontal asymptote. As you move across your graph, you don't think about the horizontal asymptote until you get to the far left-hand side. Okay, if you need to pause the video, pause it and make sure you are trying some of these on your own, and then come back and look at the recording or look at the answer key as you get stuck. Okay, I'm going to keep going. If you need to hit pause, and so on. Okay, question number 3. Get rid of all my marks. Same logic, looking for x-intercept, so I factor everything. Factor a 3 out of the bottom first. Then I get 3 times x minus 1, x squared minus 1, which factors into x minus 1 times x plus 1. It's a difference of perfect squares, so you get that. Okay, on top I get 2x plus 5, etc. You can see my factoring. Okay, x-intercepts, values for x that make the top 0. y-intercept, plug in 0 for x, and I get a negative 20 over a negative 3, which is a positive 20 over 3, which is about 6.6 repeating. Vertical asymptotes, value for x that make the bottom 0, which is at 1 and negative 1. Horizontal asymptote, if the degree of the top is the same as the degree of the bottom, then it's a ratio of the leading coefficients. So it's y equals 2 over 3. My leading coefficients are 2 and 3. Okay? Plot the points. So I plot all my vertical asymptotes, plot my horizontal asymptote, plot my x-intercepts, plot my y-intercept. Next, on the far right-hand side, as x goes to infinity, y will approach the horizontal line, y equals 2/3. It has to pass through x equals 4 and y equals 0. It has to pass through the x-intercept at 4, 0. It has to approach this vertical asymptote. The only way that can happen is if it comes up along the vertical asymptote, passes through, and now as x goes to infinity, it has to approach my horizontal asymptote. That is the definition of a horizontal asymptote. The line your graph approaches as x approaches infinity, when x gets really, really big. Next. I know it hits the y-axis at 6 point something. I know it does not pass through the x-axis, so it has to be a little parabola up there a ways. Going from the right-hand side of my asymptote to the left-hand side of my asymptote, the y values switch from going up to going down. So it comes here. It has to pass through the x-coordinate of a negative 2.50. It has to approach the asymptote just like it did on the other side, and it follows along. That was probably not the best little graph there because it doesn't pass through. It just approaches it. All right, there's a sketch of that one. Question 4. Factor everything. Notice in both the top and the bottom there is a common term. Your first step needs to be factoring out that common term. So the top factors an x out, and I get 3x squared minus 5x minus 12. That inside part, that 3x squared minus 5x minus 12, factors into 3x plus 4 and x minus 3. The bottom factors into x times x squared plus 4. That x squared plus 4 does not factor. These were x's to start with. Notice there is an x common in top and bottom. That's why I scratched them out. We now have what's called a hole. Remember the definition of a hole. When a factor on top cancels with a factor on the bottom, when you have a term on top, a factor on top, that is exactly the same as a factor on the bottom, they will cancel, and that generates a hole. The value for x that makes the hole 0 is where that hole will occur. So the value that canceled, or the factor that canceled, was an x. What makes x 0? 0. So there's going to be a hole when x is 0. How do you find the y value when you know the x value? You plug it in. I don't plug it into the original equation because I'll get something that's undefined. I get 0 divided by 0. That's indeterminate. You cannot determine, it's not technically undefined, it's technically indeterminate. You can't determine the value of 0 divided by 0. So I need to plug it into my factored, simplified factored form. So plugging in 0 into this piece here, 3 times 0 is 0, plus 4 is 4. 0 minus 3 is a negative 3. On bottom, 0 squared is 0, plus 4 is 4. The 4's cancel, and y is a negative 3. So I have a hole at 0, negative 3. You denote that by putting an open circle on your graph at the hole. That means my graph will come right up to it and jump over it and keep going. It'll include every value on the left-hand side and right-hand side of it. It will just, you'll reach in and you pluck that point out of your graph and generate a hole. Okay. If there's a hole there, there can't be a y-intercept there. We just removed that point, so there's no y-intercept. If there is a hole there, there can't be a vertical asymptote there either. Okay, and we also notice that this will never be 0, so we don't have a vertical asymptote. And if you plug in 0 in the original problem, you get no y-intercept. Okay, degree of top is the same as the degree of the bottom. So my horizontal asymptote is the ratio of the leading coefficients. The top is 3, the bottom is 1. The ratio of 3 to 1 is 3. I have a horizontal asymptote at y equals 3. Okay, let's graph this thing. As x goes to infinity, y approaches my horizontal asymptote. As x goes to infinity, y will approach the horizontal asymptote. It has to pass through the x-intercept of 3. It turns, it has no vertical asymptote. At the y-axis, there's a hole. It jumps and keeps going, passes through the x-intercept of a negative 1 1/3, and it approaches the horizontal asymptote as x goes to negative infinity. And there's your graph. There is a hole. There's no point there. That's an open circle at 0, -3. Okay, here's question number 4. All right, question 5. Top. First thing, when I factor, I notice there's a x squared common in both terms on the top. Factor the x squared out. X cubed becomes x. Negative 4x squared becomes a negative 4. On bottom, that is the difference of perfect squares, so that factors into x minus 5 times x plus 5. Finding my x-intercepts, value for x that makes the top 0 happens at 0, and it happens at 4. This is 0 when x is 0. This is 0 when x is 4. Y-intercept, plugging in 0 for x. On top, I get 0 cubed minus 0, which is 0. On bottom, I get a negative 25, and 0 divided by 25 is 0. So my x and my y-intercept are the same, which makes sense because it intersects at the origin. Next, vertical asymptotes. Value for x that make the bottom 0, which would be 5 and negative 5. Horizontal asymptote. If the degree of the top is larger than the degree of the bottom, there is no horizontal asymptote. There's a slant asymptote, and so I do long division. Okay, I'm going to jump to a new page and do that long division so you can actually see it done. So I have x cubed minus 4x squared. Remember, when doing long division, it must start with the highest exponent and decrease in descending order, including every exponent from 3 down to nothing. There's no x's and there's no constants, so I need to add those two terms. Dividing this by x squared minus 25. So, long division. First step. First term divided by first term. What is x cubed? Divided by x squared. Or, another question, what times x squared gives me x cubed? Answer, x. First step is to divide. Second step, back up. When I divide, I only divide first term by first term. Second step, multiply. When I multiply x times x squared, and I multiply x times 25. Notice I lined up my like terms, x cubes under x cubes, x's underneath x's. which is why I needed that 0x so I have something to subtract from. Divide, multiply, now I subtract. X cubed minus x cubed goes to 0. Negative 4x squared minus 0x squared. There's nothing here, and so I have a minus 4x squared. 0x is minus. A minus 25 is a positive 25x. Bring down the 0. Next step. We divide, we multiply, we subtract, we brought down. Repeat. First term into first term. X squared into a negative 4x squared. What times x squared gives me a negative 4x squared? A negative 4. And technically we could stop right here, but I don't really know that until I keep going. Negative 4 times x squared is a negative x squared. Negative 4 times 25, a negative 25 is a positive 100. So we divide, we multiply, and now we subtract. Negative 4x squared minus a minus 4x squared is 0. 25x minus 0 is 25x. 0 minus 100 is a negative 100. Repeat. X squared goes into x. It doesn't. The exponent here is larger than the exponent here. It doesn't go into it. I'm done. My answer has nothing to do with the remainder. It is only the quotient. The quotient is my slant asymptote. So go back to the problem. Looking at my slant asymptote, it's y equals x minus 4. Okay? Plot all my points. Slant asymptote. How do you graph y equals x minus 4? Y-intercept is a negative 4. From there I go up 1 and over 1. I like to go up and find my x-intercept. So if my slope is 1, that means 1 over 1. So if I go up 4 to get to the x-axis, I have to go over 4, and so it intercepts the x-axis at 4. There is my slant asymptote. Okay? Starting on the right-hand side. When x goes to infinity, my graph will approach the slant asymptote just like it would have approached a horizontal asymptote had I had a horizontal asymptote. As x goes to infinity, y will approach the slant asymptote, either from the bottom or from the top. It can't approach from the bottom because if it were to approach from the bottom, it would have to also approach the vertical asymptote. So it has to come from here and go through the x-axis and approaching the vertical asymptote, and it doesn't. Why doesn't it? Because it doesn't cross the x-axis over there. So it doesn't look like that. It has to approach the asymptote from the top. So it approaches it here. It's got to go through, or it has to approach the vertical asymptote. So at some point in time, it has to turn and go back up. Why can't it go down? Because it does not go through the x-axis on the right-hand side of that vertical asymptote. It does go through the x-axis on the left-hand side of the vertical asymptote. Just like a horizontal asymptote, you can pass through the slant asymptote. So it passes through the slant asymptote, cruises up here, has to turn and hit this x-intercept. Why did I bounce off the x-intercept instead of passing through? Remember when we did polynomials, if the factor that gives me that x-intercept is squared, it will touch and go back up. The x is being squared, and so it bounces off x equals 0. So it comes down, bounces off, and turns and approaches the asymptote. Okay? Next, you can't see it on my paper. I ran out of room. We have another part, right? We have parts between each asymptote. So we have a piece out here, we have a piece here, we have a piece here. Okay, so I need to find this piece on this left-hand side. So what does it look like over here? Same logic. If it was on the right-hand side going up, on the left-hand side of the vertical asymptote, it'll go to negative infinity. It can't pass through my x-axis out here, so it has to be in this little corner out here, just like it was in the upper corner. That was a good one. I like that one. All right. Get rid of my mess. Question number 6. Same thing, graph everything. Not graph, sorry. Factor everything. Top factors into x minus 2 times x minus 2. Bottom factors into x minus 3 times x minus 3. Another way of writing the top is x minus 2 squared. Another way of writing the bottom is x minus 3 squared. Zeros or x-intercepts are values for x that make the top 0. Vertical asymptotes, values for x that make the bottom 0. You can't quite read my 3 there. Y-intercept, plug in 0 for x, and you get 0, 4/9. Horizontal asymptote, the degree of the top is the same as the degree of the bottom. So it's the ratio of the leading coefficients, which is 1. Okay, right-hand side of my vertical asymptote. We have a horizontal asymptote at 1. When x goes to infinity, y will approach the horizontal asymptote, either from the bottom or from the top. It's got to be from the top because if it was from the bottom, it would have to go through the x-axis, and it doesn't. So my graph is approaching 1 from here, and it turns and goes up. Remember, I've always said, when I go from the right-hand side of the vertical asymptote to the left-hand side of the vertical asymptote, it will switch. If it goes to positive on the right-hand side, it'll go to negative on the left-hand side. So why am I not coming from here with my graph? Remember, we also talked about if your factor that gives me the vertical asymptote is squared, then it will not do that. It'll be on the same, it'll go the same direction on each side. So if it's squared, it'll both go up, which it is. This, whoops, wrong one. This is x minus 3 squared. So my vertical asymptote is the factor that gives me the vertical asymptote is squared. And so it'll approach that asymptote going up on both the right-hand side and on the left-hand side. So it's got to come down from the top. Why did I bounce off the x-intercept instead of passing through? Because that factor is squared. It bounces off as x goes to, it passes through the y-intercept of 4/9. As x goes to infinity, y will approach the horizontal asymptote. This is not there. Okay, hope that helps. All right, off to the newer stuff. Get rid of all my marks. All right, 7 through 10. First thing I do, shift my horizontal and vertical asymptotes. Horizontal asymptote and vertical asymptote for y equals 1 over x is the x and the y axis. So I'm going to shift my x and y axis, or my vertical and horizontal asymptotes. This tells me to go up 2. There's nothing that's being added or subtracted to the x to make it go right or left. So my vertical asymptote doesn't change. This intersection is my new origin. From there, I'm going to graph my parent function that has been vertically stretched 5 units. One easy way of graphing that is, if x is 1, think about what 5 divided by 1 is. If x is 1, y is 5. So from my shifted origin, I go over 1 and up 5. 1, 2, 3, 4, 5, and I get that point right there. If I go over 5, then 5 divided by 5 is 1. So I go over from my shifted origin, 1, 2, 3, 4, 5, and up 1 from my shifted origin. And I get my graph, plot my points, sketch the graph through it. Same logic on the left. If I go left 5 from the shifted origin, I go down 1. If I go left 1, I go down 5 from the shifted origin. And I get my graph. Okay. Question 8. Same idea for question 8. First step, x minus 3 shifts my vertical asymptote to the right 3. The plus 1 shifts my horizontal asymptote up 1. So my new vertical asymptote is no longer the y-axis. It's at x equals 3. And my new horizontal asymptote is no longer the x-axis. It's at y equals 1. From my shifted origin, from this point right here, put it in a different color, from this red point right there, I'm going to move over and up. So if x is 1, y is 7. So look at that point there. It's 7 times what the original y value was when x is 1. If x is 7, y is 1. So from my shifted point, I count over 7 units, and up 1, and over 1, and up 7. Get my 2 points, sketch a curve, and I've got that. Same logic going left. If I go left 7, then I go down 1. If I go left 1, I go down 7, and I sketch my curve. These dotted lines are simply reference lines. They're asymptotes. They aren't actually part of the graph. Question 8 and or question 9 and 10. Question 9, same idea. First step, my vertical asymptote shifts left 4. My horizontal asymptote doesn't change. It's still at y equals 0. From my shifted origin, from this point right here, when x is 1, and y equals 2 over x, if x is 1, y would be 2, but it's a negative 2. So when x is 1, instead of going up 2, I'll go down 2. If I went over 2, I would go down 1 and sketch a graph. Same logic. If I go left 1, I'll go up instead of down. And if I go left 2, I'll go up 1 instead of down. And there's my new curve. Horizontal asymptote, y equals 0. Vertical asymptote, x equals negative 4. There's nothing out here causing my graph to shift up. It only shifts to the left 4. Okay. Question 10. Right 1. Vertical asymptote is right 1. I covered up my other mark. Left, not left 4, but down 4. So my horizontal asymptote is down 4. If x was 10, from my shifted point, if I go over 10, so we're over here at 11, I go down 1. If I go over 1, I go down 10. So we're down here at 14 because I started at negative 4. Sketch a point or sketch a curve. Same logic. If I go left, now I go up because of the negative. If I go left 10, I go up 1 because of the negative, and I have my curve. Okay, I think those are going to be fairly easy once you get the hang of them. Question 11. Give the equation of a rational function that has a vertical asymptote of x equals 4 and a horizontal, and a vertical asymptote at x equals negative 2. So vertical asymptotes are values for x that make the bottom 0. So my bottom has to be x minus 4 and x plus 2. Okay, so those are my factors if you couldn't read that. Horizontal asymptote of 3. How do you get a horizontal asymptote to be 3? Well, if the degree of the top is less than the bottom, it's 0. So it's not that. If the degree of the top is the same as the degree of the bottom, it's the ratio of the leading coefficient. Those are the only two options for having a horizontal asymptote. So the ratio of the top to the bottom has to be the same. Not has to be the same, sorry. The degree of the top and bottom has to be the same. And my ratio must be 3 to 1. If I were to multiply the bottom out, I would have a degree of 2. So the top must have a degree of 2. So I put an x squared on top. I also have to have the ratio of the leading coefficients to be 3. So I have a 3 on top, I have a 1 on bottom, I'm good. Now, it doesn't say anything about having x-intercepts. So if I were to change this and say there's no x-intercepts, how would I do that? How would I modify, because according to what I just put in, my answer, I developed or I generated x-intercepts. The problem doesn't say whether I have or don't have x-intercepts. So what if I changed the problem and said with no x-intercepts? What do I need to put on top so that there's no x-intercepts? I need to put something up there that has no value for x that makes the equation 0. I need to add something, anything, 1, 2, 3, whatever. That equation has a leading coefficient of 3, and so my ratio of the leading coefficients is 3 to 1, so it's 3. That has no x-intercepts because there's no value for x that'll cause that equation to be 0. Okay, question 12. X-intercept at 3, so the top needs to be x minus 3. Vertical asymptote at 0, and x equals a negative 3, so I have x and x plus 3. If you can't read my writing, it should have been this. Done. 13. Rational function that has a slant asymptote. Degree of top has to be larger than the degree of the bottom. I put an x cubed over an x squared. Vertical asymptote, there isn't a vertical asymptote. The bottom can't be 0, so I know it has to be x squared plus something. Put anything you want there, which is why I had to put an x cubed on top, and I didn't have like an x squared over x, because I couldn't, I'd have a vertical asymptote had I had x squared over x. So I knew it had to be x cubed over x squared plus something. Add whatever you want right here. I put a 9, put a 10, put a 1, put anything you want there, besides a negative. Okay, question 14. Give the equation of a rational function that has a domain of all x. You read this by saying all x so that little line right there means all x so that x is not 3. X can't be 3. What does that look like on a graph? If x can't be 3, what does that look like? That means I have a vertical asymptote at 3, right? Vertical asymptotes occur when x can't be that value. So x can't be 3. So a vertical asymptote at 3 means I have 1 over x minus 3. And a range of y can't be 2. So I have a horizontal asymptote at y equals 2. I have more than just a horizontal asymptote. I can't have a function like we had on questions 1 through 6 because those can pass through the horizontal asymptote. It has to be an equation like we have up on 7 through 10, where it's not going to pass through my horizontal asymptote, which is why I graphed it or drew it, wrote it the way I did. And I put it as y equals 1 over, let me rewrite it. I wrote it as 1 over x minus 3 plus 2. That has a range where y will never be 2. It has a domain where x will never be 3. All right, hopefully you are getting better at these graphs. Be ready for the quiz on Wednesday. Good luck.